Welcome back to part 4 of our live training session here with our K24 swapped Civic Si. This training module, we're going to take a look at doing the part throttle cruise calibration process. This is going to be sorting out our fuel spark timing as well as our variable cam control and our fuel injection timing. We have a lot of things to cover. Let's jump in so we can check this out. Welcome back to our live training session here with our K24 swapped Civic Si. This training module, we're going to jump in and take a look at how to dial in our part throttle cruise area of operation. This is going to be including looking at fuel tuning, spark timing tuning, our O2 lambda feedback control tuning. We're going to look at doing injection timing tuning and also variable cam control tuning. So we have a lot of different aspects that we have to consider when we're dialing in part throttle here on a Honda K-Series engine. We're first going to go over where we left off in that last tutorial, the crank index offset value. I mentioned that I was going to go out and check it with a timing light and then come back into this tutorial and then just discuss what I found. So let's go and talk about that real quick, and then we'll talk about what we need to edit and change in a few different tables here in preparation for going through the calibration process in this tutorial. So let's take a step back and let's go here into config and let's jump in here to engine setup and then into crank index offset setup. Now in here, the crank index offset value, we can see I returned this back to 0. When I had the engine running and I was able to actually get a good generation of a pulse from the timing light and looking at the mark that I made, the highlighted mark on the top dead center on the balancer, I locked my timing at 15 degrees. On the dial wheel for my balancer, I actually have a dial wheel that I locked it at 15 degrees. So I've locked it here at 15. I've set my timing light to 15 degrees, which allows me to shoot for that top dead center mark. I was able to get a very clear view with good pulses from the timing light now that the engine was running and running stable. And I determined that the crank index offset here at a value of 0 was dead on to where it should have been for the timing. So it looks like the crank index offset, when we're working with these pre-selected OEM crank patterns that we can go in and set with the Emtron, that the crank index offset being 0 is going to assume that the engine is all assembled correctly in its OEM orientation in terms of the cam timing and the chain timing, and you are able to rely on this as a good starting point. Normally when I'm working with Emtron, I'm usually doing things with external aftermarket crank triggers, and everything's going to be completely thrown off from an OEM pattern. So this is the first time I've actually sat down and dealt with an OEM pattern on a vehicle here with Emtron. So that's something I've learned here in this tutorial, that the crank index offset being 0 is valid, assuming that the engine is timed correctly mechanically, which it is, and everything here is working out properly. So 0 is what I ended up with, and that looks good. So that's what I wanted to just mention here as we're coming into this tutorial. Let's go back into tuning and let's talk about a few things. Now, what we're going to be doing here, very first thing, is taking a look at doing our fuel tuning. And fuel tuning, I am going to be simply referring to our VE table, or air mass tuning. So we know we have our equation fuel mass is equal to air mass divided by target air fuel. We've established our target lambda target air fuels in our target lambda table. We have the injector data sorted out. We have the flow rate and the dead time sorted out. So what we're left with here to really determine is if our VE values in here are an accurate air mass representation. Now we're going to use our lambda control feedback. We know that we have our lambda control. We can see we have our sensor fuel correction total. This is how much it's correcting based on looking at the actual lambda, comparing it to the target lambda. So we have our wideband fitted here. It's feeding in a lambda signal. It's comparing against the target. It's making an adjustment to our injector pulse width as it's coming out of and passing through that fuel and airflow model. So we have our injector pulse width is being corrected by a certain percent. That percentage is highlighting an error. So if it's taking away 10% or adding 20%, that means that our volumetric efficiency values in this case are something that we need to update. That means they're too low or too high from our table. So we're gonna go through and sort that out here. I can't talk over this car here on the chassis dyno, on my mainline dyno right now. So we're gonna be talking about what I'm going to do for logging, and then we're gonna play it back and start to dissect the data log using a playback feature and using an overlay feature here in the table. It's actually quite simple. This is a better way to try to calibrate and tune, especially if you don't have a chassis dyno at your disposal. You can go take a data log, drive it around for a while, come back in and play it, and use the overlaid feature through the data logging. Again, we'll talk about what this all means here as we go through, but we are going to deal with that first using the lambda feedback control as a guide or a means to show us what we need to adjust in the VE table. It's pretty simple. Then we're going to take a look at doing our spark timing optimization. So we have our chassis dyno here, and we have a live torque output. This is better left to a dyno, a chassis dyno that gives you a torque output to really determine what kind of spark time we would have in part throttle conditions. If we go back in here to ignition, we go to our main ignition table.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.